All right. Hello, everyone. My name is Amir Meimand. I'm Principal Solution Engineer in the strategic team of Tableau. And during this session, I'm very happy to present one of the newest feature of Tableau released in 2020.3, which is table extensions. And it is one of my most favorite feature of Tableau, which basically bring the next level of flexibility in the integration capability of Tableau with external service, including like a scripting language like R and Python and other AutoML platform. However, before jumping into the discussion about table extensions, I want to give you a very brief introduction about like the integration capability of Tableau with like data science platform and describing how this capability can enable data scientists to bring their own model, bring their own code into Tableau and make them available and accessible to the rest of organization. So Tableau historically revolutionized business intelligence by letting domain experts to explore their own data without necessarily having any like knowledge of like database analytic or visualization. So today, data scientists and advanced user can bring their own machine learning model or algorithm or code into the same platform. Today, you can bring your code like from anywhere. You can write your code in like any scripting language or Python, Java, C++, and then bring it into Tableau. Tableau also has like native integration with most of AutoML platform in the market, like Amazon SageMaker, RStudio, Data Robot, RapidMinder. So if you are building your machine learning model with any of these platform, you can natively integrate this model with Tableau, meaning that your end user can call this model in the real time and get the result of this model, either prediction or whatever is the result of this model. And the main advantage of bringing this model into Tableau is that your business user can have access to this advanced model, and at the same time, you can bring your data from anywhere by taking advantage of Tableau data connection. Most of the time, data transformation is a challenge for for data scientists. Like as a developer or data scientist, you may have your code or model in like R, Python, or SageMaker. However, the data for which your end user want to apply this model might be like somewhere else. It might be in a Snowflake or Amazon Redshift or Google BigQuery. So bringing this data from where it is to where the model and the code is usually very time consuming. So by data science integration capability of Tableau, you can connect to pretty much any type of data source and bring your data, and at the same time you can bring your own model, bring your own code, and then apply this model to your data, and then enable your business user to interact with this model in the real time. And our main goal by bringing this capability to the market is to bridge the gap between data scientist and business user. So as I mentioned earlier, data scientist and advanced user has like ultimate flexibility. They can just build their own model, write their own code with like any tool or any like platform as they prefer. So there is no limitation on that. So they have like ultimate flexibility on this part, and then using Tableau as a model agnostic deployment platform, meaning that you can deploy any type of model, any type of code, any type of algorithm on Tableau. There is no limitation on that. And then on the other side of the gate, your business user, the end user who may not have like any like coding or data science or machine learning expertise or background, can interact with this model in the real time as easy as a drag and drop. And as I said earlier, the main goal here is just bridge the gap between data scientist and business user and democratizing advanced analytics and machine learning. Because as a data scientist, you will be able to make this advanced model available to the rest of organization, and then they can interact with them in the real time. So Tableau has like integration capability with almost any like scripting language and AutoML platform in the market. However, the main focus of this session is on integrating Tableau with Python, which is like the most popular scripting language in the area of data science and machine learning. But so my focus in this session is integrating Tableau with Python. However, the integration with other scripting language would be like very, very similar. So before talking about like table extensions and what capability it can bring to the table, I want to give you like a brief introduction about how you can integrate Tableau with Python, because maybe some of you are not familiar with this capability of Tableau. So that could be like a good background. So uh, integration of Tableau with Python required a Python library which is called like TabPy. TabPy is an open source Python library which is developed and maintained by Tableau product team, and it is officially part of Tableau product, meaning that as a Tableau customer, if you are using TabPy and if you have like any issue with like the configuration or setting, a Tableau support team will support that. TabPy is an open source library. It is free, so you can install it on your local machine or on your server, very similar to any other like Python package. By just using like pip command, pip install TabPy, will install like the latest version of TabPy on your local machine, in which you have like your Python engine. And then after installing TabPy, you need to run it. And when TabPy is running, it is acting as a listener. So it listens to your Tableau to see if Tableau sent any like Python code to execute. And if it does, TabPy will run this code and then return back the result to Tableau, so the end user can consume this result to build their own visualization. Now, in addition to installing and running TabPy on your local machine or local server, you need to configure Tableau, because Tableau needs to know where your TabPy and Python engine is running. On Tableau desktop, the configuration is very straightforward, going to help, setting and performance, manage analytic extension connection, and then select the connection type. In this case, we are selecting TabPy because we want to integrate Tableau with Python. And then in the TabPy connection, we need to specify the host name. The host name is the name of a machine or server in which TabPy is running. In this specific use case, I'm running TabPy on my local machine on my laptop, so the host name is always like localhost, and the default port number is 9004. And after that, you are able to write and run your own Python code in Tableau, and I will show that how you can do that in like in few seconds. If you are using like Tableau Server or Tableau Cloud, the configuration would be very similar. So by going to setting extension, then you can add like analytic extension by selecting like TabPy as connection type, specifying the host name and port number, and then you can run your Python code in Tableau Server or Tableau Cloud as well. So now, saying that, let me show you like a quick demo of like Python integration with Tableau um, mm, mm, as a table calculation, and then talking about its application and its limitation. And then after that, I will jump into like table extension to see like what type of like flexibility table extension bring to the table. So let me first show you like how I can run TabPy on my machine. So I already installed TabPy on my local machine. So as I said, you can just install TabPy by writing like pip install TabPy, and then it will install like the latest version of TabPy. I already did that. So the next step is just running TabPy. So I just type TabPy, and then it will run it automatically. So now my TabPy is running, so I can just integrate it with my Tableau. And if I go to like my Tableau desktop, by going to help, setting and performance, manage analytic extension connection, I would select TabPy as the connection, and then my host is local host and port number is 9004. If I test connection is built, and then from now on I can just run my own Python code in Tableau. Now let me show you a very like quick example of like Python integration with Tableau. So this dashboard is built by one of our customer who is running like retail business in Brazil, and then they ran a marketing campaign and then gather their average customer spend in the course of like 6 months before and after running the marketing campaign. And then by selecting each of these state, I can see like the average customer sales increase significantly after running the marketing campaign. However, the business question here is that if this shift in the market is like statistically significant, or it is the result of like some noise in the market. And this is one of the situations that you want to run some type of like advanced statistical test in the form of like A/B testing or t-test and get the result. So I already write a Python code for that, which result is just shown as p-value in my dashboard. So when the p-value is too small, it means that the marketing campaign was successful. And the main advantage of this capability is that as soon as I select like a different state, you may see that this p-value change because Tableau automatically rerun my Python code, and I can just see the result of my statistical test in the real time. And I can just run it for any subset of data. Like I can select like any part of data as I want, and then I can get like the result of this test. So as an end user, I don't need to have like any knowledge of like statistical testing or Python coding. I can just build my own dashboard as easy as like drag and drop. Now let me show you how it happened in the back end. So integrating and writing your Python code in Tableau is as easy as creating a calculation field. So here I create a calculation field. I call it like t-test. And if I open this, um, in this calculation field, I have my Python code. So I use like a script function. A script function enable you to run your script in Tableau directly. And then here you can imagine that this is like your Jupyter Notebook or Python IDE, in which I can just import like any type of like Python package that is available on my Python engine server. I import like pandas, numpy, scipy, and then I get the data from the visualization. arg1 and arg2 are referred to two input element of my Python code. arg1 is coming is referred to the first element, which is like average sales. This is my target variable that I want to analyze, and arg2 refer to the second element, which is like the time period before or after running the marketing campaign. Then I write the rest of my code to just run the t-test, and then I return like this p-value, which is one single number. So this is like the integration capability of Tableau with Python as table calculation at a row level. So by this capability, you can just write and run your Python code in Tableau directly, and this can be like any type of code. However, one of the limitations that this integration has is that since it is run at a row level, your Python code can only return like one column, list like one single value or one column. So then Tableau will be able to map it to the data mark in the visualization. So saying that if your Python code, for example, generates like a full table with like multiple column, this method may not be applicable or may not be very efficient. And this is the limitation that we are trying to tackle by offering table extensions. So table extensions enable you to incorporate your Python scripts at a data source level, and these Python scripts can generate like a full table with like a multiple column, and the output of your Python scripts might be very different from the structure of your input data. And then you can incorporate it at the data source level, and then enable your end user to have access to the result of your Python code. So in the next part, I'm going to talk about the table extensions, and we are going to specifically focus on one business problem. So we first like define the business problem, what we want to achieve, and then see how table extension can enable us to solve this business problem. All right, now let's talk about like the business problem we are trying to solve. So the business problem we have is portfolio optimization, which is a very popular problem, especially in finance and banking industry. Portfolio optimization is about to find the best combination or the way of like allocating your capital or investment between different stock to maximize your total rate of return and hopefully minimize the risk of investment, assuming that the stock and the companies are going to perform similar to the historical data that we have. And if you search for portfolio optimization, you may find like a lot of resource about it. But let me jump into Tableau to elaborate on the detail of problem a little bit and see like what type of like challenge we may have if we want to approach this problem with Tableau without like table extension. And then after that, I will show you like the final solution, how table extension can accelerate like the creation of the solution. So in this simple example, I have only like two stock, Amazon and American Airline. And I'm assuming that these two companies are going to perform like very similar to their historical data. So I created this like daily change calculation, which basically calculate like how much every day their stock are going to like increase or decrease, the difference between like open price and close price, because I'm going to do like daily trading. And now let me create a time series visualization to see how was like the historical change of like these two. So you may see that Amazon has like a like less rate of return. Like for example, in most of the day we lose more money rather than gain. So if I get like the summation of like last year, if the company is going to perform similarly and I do like daily trading only on Amazon, then I may lose like 2% of my money. American Airlines perform like better. So if I invest all of my money in American Airlines in doing like daily trading, by end of the year I should expect like 60% increase as rate of return. However, total rate of return is not like the only factor. If you look at like this time series, we may see that American Airline time series has like more variation. So which means that investing in American Airline is subject to more risk. So there is a trade-off between like rate of return and the amount of risk that you should expect. And because of that, we don't want to invest all of our money in only one company. So we want to split it between like two or multiple company to find this trade-off between like rate of return and risk. So to do that, I created like these two parameters, Amazon and American Airline. So by default, I'm going to invest like 50% of my money on Amazon and 50% on American Airline. And now I create like this like daily change for all, in which I just combine like the investment of these two company, 50% on Amazon and 50% on American Airline, and investment is just conditional calculation field based off like the company. So if I visualize like this new investment, which is like 50% on Amazon and 50% on American Airline, this is like the behavior of my portfolio. And if I get like the summation of this, you may see that the expected rate of return is around like 30%, and it has like less risk comparing to like spending all of my money on American Airlines. I can get rid of like the date and only look at like the total rate of investment, and also I can calculate like the standard deviation of like this daily change, which can be used as a matrix to indicate like the risk of my portfolio. So now I can just play around with these parameters. What about like I spend like let's say 20% on American Airline and 80% on Amazon. You may see that my basically my standard deviation reduced, but my rate of return also reduced. So this is like the combination in which I should expect like less return from my investment, but it also has like less risk. But nevertheless, this approach is not like practical, because there are like countless number of scenario. Like I only try like two of them, like 80% on Amazon, 20% on American Airline. There are like countless number of scenario that I can explore. So basically, I need some sort of like simulation engine at the back end that generate hundreds of like scenario for me automatically, and then I can calculate like this matrix for each of these scenario, and then doing some comparison to see which of these scenario is like applicable to my business. In addition to that, most of the time we are not going to invest only on two stock. We want to consider like more of that to diversify our portfolio. And in this case, as a matter of fact, I have like more than like 57 stock to be considered for my investment. So creating like parameters for 57 stock is like not practical. And in addition to that, like doing this like scenario planning like manually would be like very inefficient. So this is the situation that we can use some external service like R or Python at the back end to do this simulation for us, generate like hundreds of scenario for us like automatically. And then in Tableau, I can calculate all of these metrics like rate of return or risk or any other metrics that is relevant to my business, and then do the comparison between different scenario. So in the next part, we are going to use Tableau table extensions to create some sort of like simulation engine that simulate multiple scenario for us, and then in Tableau we will calculate like different metrics for each of these scenario, and then do the comparison, and then select the investment scenario which is like more relevant to our business use case. All right, now let's see how we can build this solution by using Tableau table extension. So I'm in my Tableau desktop, and the first step is connecting to my data. So most of my data is available as a CSV file, so I'm going to select like one of them. However, I want to start my data source by bringing my Python code, which basically um, build like a bunch of scenario for me in the form of simulation. So I'm going to remove this. And in Tableau 2020.3, you see like this new entity in your data source, which is like new table extensions. And this is basically enable you to incorporate your Python code or R code or any other like external service at the data source level. So let me drag this into my data source, and then it opened this new window, which enable me to just write my Python code as I want. So your Python code may or may not have like any input data. Like for example, you can just write a Python code that generates some number by themselves, or they extract data from like external data source in the form of like calling API or something else. Or your Python code can have like like input data to just manipulate this data. So in this case, the input data of my Python code is the name of like the stock, the name of the company that I'm targeting to do the investment, and I want to like run simulation for them. So the name of a stock is available on this data source. So basically, you can use like any data source that is supported by Tableau Data Connection as an input to your Python code. So I'm going to drag this here. And now Tableau consider like this table as my input table. So this input table would be like the input to my Python code that I can use. Now here, let me talk a little bit about like the data structure transformation between like Tableau and your Python script. And let me jump into my slide. So basically, Tableau send like this input table in the form of like JSON, which is basically translated into dictionary to your Python. So basically, in your Python code, arg1 refer to this object, which is a dictionary, and the key of this dictionary is the name of like your table column. Like symbols, it is one key, and cap is another key, and the value for each of these key is the list of like the real value. So basically, the key is symbol, and the value is like the name of a stock. The cap is the key, and the value is like the actual value for this. So this is the format or the structure that Tableau sent this table into your Python code. And to have access to each column of this like input table, there are two options. If you need only like one or few of like this column, you can just call them directly by using like arg1, like the name of column. You can have access to all value of this specific column in the form of list. And in this specific use case, I just need to have like the name of like the stock in the form of list. So I'm going to use like arg1, like the symbols, and then I have like the list of all the stocks. Alternatively, you can just convert this dictionary into like pandas data frame by using like pd data frame and arg1, and then Python automatically convert this like JSON or dictionary into like pandas data frame. And yeah, most of people are more comfortable of like working with pandas data frame, but there are like two different ways to have access to the input data. So let me jump back into my Python code. So as I said here, I only need like the name of like the stock. So let me paste my code here. So basically, with this part of code, I import like two library random to generate random number, pandas to work with pandas data frame, and I define like this global variable because I want to generate like 1000 like simulation. I can increase or decrease that, and this stock getting like the value from like the first column of my input table, which is like basically my the name of the stock or the name of the company for which I want to generate like simulation. And the rest of the code is basically my simulation logic. I don't have plan to go to detail of it, but the code is pretty much simple. We just generate bunch of random number in the form of like investment in different like stock, and then user can calculate like the other matrix based off that. But now let me um, run this code, and then we can see like the output of this code directly in this view to examine it and make sure that it is like aligned with our expectation. Now the code is run, and if I click on output table by clicking on update now, I can see like the result of my Python code. So basically, Python generate like 1000 scenario or 1000 run for me. So for run one, it's about like spending like 10% on XRX, 0% on the second company, 70% on the Bank of America, 0% on the rest of them, 30% on like Microsoft, and so on. And then it generates like this is like all the investment for like the first scenario. For the second scenario, we have like different situation, investing like 30% on DD. I assume this is like Dell, or investing like 2% on TM, which is like Texas Instrument, and so on. So, uh, mm, so this part of Python code generate like 1000 scenario for me. Now I can just incorporate the rest of my data, which is like the historical performance of this company, and then do the rest of calculation in Tableau. So I'm going to rename this to like simulation, and now I can back to my original data source. And one of the advantage of this capability is that you can combine your Python scripts with like any other data source that you want. It can be like a CSV file, a SQL table, or anything else. So now I'm going to add like the stock price, which is like the historical performance of this data, and then by drag it into the data source, I can just join it back to the output of my Python code, which is very powerful because you can join like your Python script or your machine learning model with like any type of data that is relevant to the workflow of your analytic. So Tableau treat them as like a relational table, so I can define based off like which field I want to join them based off like the symbol, which is like the symbol of company. And now I have like a full data source, which is like the combination of my Python code and the historical performance of this company. And then I can go to my Tableau dashboard and do the rest of calculation automatically. So one of the main advantage here is that to run this Python code, you don't need to have like additional infrastructure or pipeline or ETL. So this Python code is incorporated into your Tableau dashboard. So every time that user open up this dashboard, this Python code will be automatically run, and they have access to its results. So there is no need to do any like running any pre-processing or writing back data into database. Everything is incorporated and embedded into your dashboard. Now, if I and the result of this Python code will be cached in the memory by using the hyper technology. So as the user interact with this result into dashboard, they may not see any performance issue because the result of Python code is cached on the memory. Now, if I go back to my dashboard, I have like these two field which is coming from like my Python code, the number for the for this for each run of simulation, and also the investment option, and then I have like the historical data. Now I can do like any type of like custom calculation as I want to, just decide like um, which scenario is applicable to me. So I'm going to paste like this pre-calculation field, which basically calculate like the daily performance of like each scenario. I'm using like the level of detail to fix each scenario, fix each date, and then calculate like the daily movement for each of these um, company. And then I have like additional field to calculate like the rate of return. In the finance, there are like many ways to calculate like the rate of return. And one of the advantage of doing it in Tableau is that your business user has this flexibility to use like any type of formula or calculation that is relevant to their department or to their industry. But here I'm using like the simplest form, which is like getting like the summation of like rate of return over a year. And then the last part is just basically calculating the risk. And again, there are like multiple formula to calculate the risk, but the simplest one is just calculating like the standard deviation, which is like the indication of like how risky this portfolio can be. So now I can just easily do the comparison between different scenarios. So my Python script generate like 1000 scenario for me, and I can create like this beautiful scatter plot to to show to see the trade-off between like rate of return and risk. So as I mentioned earlier, there is usually trade-off between risk and rate of return. So you may have like some portfolio like this one, which has like a very high rate of return, close to like 41%, but there is like more risk associated to that. There are some other like portfolio like this one with like close to like 10% rate of return. Less money will get back, but the risk correspond to that is like less than average. So depends on like what level of risk your investment want to tolerate. You can decide like which of these scenario is like more applicable to you. And another advantage here is that as a data scientist or developer, you need to only write code to generate like this simulation, this scenario, and the rest of calculation and also building like any type of visualization can be done in Tableau as easy as drag and drop by the end user. So now let me show you like the final dashboard that I built like uh, prior to this session. So this is like very similar to the one that I showed you. So here we have like the list of like this here we are creating like this scatter plot for all of like this scenario, and to see like the risk associated to that and the rate of return. By selecting each of these portfolio or each of this scenario, I can see like the breakdown, like how much I should spend on invest on each of these company. Like American Express is the highest one with like close to 20% investment. Then I have like Philips with like 70%, Delta with like 15%, and so on. And also I can see like the daily rate of change for this specific portfolio. And if I want, I can just like zoom into like the offset date of like 3 days to see the detail of that. So that's a very easy way to build like a variety of visualization, and we can do this investigation for any of these scenario as we want. We can just jump between like two different visualization that is more appropriate for our audience. So by incorporating your Python code into Tableau, you can bring like a lot of flexibility by combining like advanced analytic machine learning simulation combined with the power of visualization, and enable your end user to interact with this model, interact with this result in the real time, and find answer to their business question. And again, as I mentioned, this Python code will be embedded and incorporated into your Tableau dashboard. And so you don't need to have like any like extra infrastructure or pipeline or pre-processing to pre-process this simulation prior. Everything will be run automatically as soon as you open like your Tableau dashboard, and then you have access to all of these results. Another advantage is that if your business user want to get like another round of simulation, he or she can just easily refresh this data source, and Tableau rerun your simulation engine and generate like a new set of like simulation for them that potentially come up with like some new scenario. So you may see that this scatter plot changed because Tableau automatically rerun my Python code and generate some like a new scenario for me. So again, there are like many like flexibility here in terms of like customizing your analysis. So for example, for some of the investors, in addition to risk and rate of return, the diversity of portfolio is also important because they don't want to put all of their money in like one industry or few industries. And obviously you can do that like automatically in Tableau. Like for example, in this case, I created like this calculation field, which is like a diversity, and for each portfolio, it calculates like the distinct number of like industry. So I can just add it as a filter to this view, and then enable my investors to select like the diversity degree of their portfolio as they want. So let's do that in the real time. I can add it as a filter to the dashboard. I can add like a apply button for it. So let's say we only want to consider the highly diverse like portfolio that has like more than like 12 distinct industry. And then by applying this filter, I narrow down to only the scenario that are like highly diverse. So they have like at least like 12 to 14 like different industries. So you may see that the number of color here is like more diverse because we have like only United and American belong to the same industry, and then Boeing and American Express are from like another industry. So there are like a lot of flexibility here in the term of like what type of like custom calculation you want to do downstream to just find the solution or the scenario which is like more applicable to your business. So that was the main use case that I had for this session. And as we saw during this session, Tableau enable you to just bring any type of like advanced calculation, advanced algorithm, advanced like model to your end user, and end user have access to the result of like this model in the real time, similar to like simulation engine that we have, and then they can build like customized calculation at top of this model down the road. All right, so that's the end of solution building. So we saw how we can build like a solution for portfolio optimization by bringing Python code and combine it with like other data source, and then enable end user to explore like a different scenario, different like portfolio options, and then examine it based off like any business metrics that they have in mind. But before ending the session, there are a couple of like expected questions that I'm trying to answer. The first question is if the user are able to change the parameters of code dynamically from Tableau dashboard. The answer to this question is yes and no. No, because at the time being we are not supporting sending parameters from Tableau dashboard directly to the Python code to the table extension. However, there is a workaround for that. So basically, if your Python code is getting input data from any like SQL friendly database, you are able to control the input of this Python code through like the custom SQL, which can be empowered by dynamic parameters. Let me show you a quick example of that. So this dashboard is built by running like simulation for inventory control, and we are running like different scenario for inventory management based off like the capacity of warehouse. And in this situation, the end user wants to be able to run this simulation for different value of capacity to see which one has like a more profit or lower like lost product. So if I go to like the data source for this one, I have like only like one table extension which is running my simulation, and this simulation getting its underlying data from like a SQL table. So I can write a custom SQL for the input data. So I get like all of this value that I need for my simulation, like the starting stock, the mean, the standard deviation, the lead time, the probability, and so on. And then I can add like two other value, the capacity and number of simulations. And these two value are coming from like the parameters that exist in my Tableau dashboard. So, and one of these parameters is the capacity. So basically you can control the underlying or the input data of your Python code by using like the custom SQL and dynamic parameters. So the user can change these parameters dynamically in Tableau dashboard. Now let me go back to my Tableau dashboard. Let's say I want to run this simulation for a different value, like 2.5. So by changing this one, I need to like refresh my data source to rerun my Python code. Now Tableau rerun my Python code for this new value, which is like the new value of capacity, and then it will return back the result. So this is like the updated result for this specific value of capacity. I can pass like multiple value, like let's say 150, 250, and let's say 3000, and then my Python code basically parse this value and then run my Python code iteratively for these three values. So I can just do the comparison to see like which of these capacity give me like a better profit or better like loss product. So since it is like three value, it takes like more time for the simulation to run. So now you see that I have like three different values. So it seems that my profit will be maximized at like capacity of like 2.5, and by selecting any of this I can just see the corresponding distribution. So there is this is like one workaround to control like the input of your Python code by writing like a custom SQL. Again, this workaround only work if your underlying data is coming from like a SQL friendly database. So it does not work if your underlying data is CSV file or any other database that does not support like a SQL or a SQL language. The other question is like what type of model or what type of code you can bring to table extension, and the answer is that you can bring like anything. You can bring like any type of model or any type of code. I have like another dashboard here in which we build a table extension empowered by a very sophisticated object detection model. So basically, the user uh, can put like the photo URL on this parameter, and then Tableau rerun the object detection model for you, and then detect like what type of object exists in your in this photo. So let me try like a very big complicated photo, which is like this one with like many objects on that. And then if I refresh my data source, Tableau rerun your object detection model, and then shortly you will see like the list of objects that model detect from this picture. So if I uh, maximize it, so these are like the list of like object that the model detect, like cat, which is like this cat, like the laptop, the person, which is this lady, the bottle, the cup. So there is no limit on the type of like model that you can bring. We can try like another like picture, which is like again cat and dog, and then we can rerun our object detection model, and then it will automatically detect like all the objects that exist in this table. You can, and it detect like one person, so the model did not work well here, but it detect like both cat and dog. And you can just move it to the next level by even like visualize the detected option. So I have another dashboard here in which if I select any of these picture, I can see like the model basically specify like each of the object that it detects. So this is like a black and white, so it may not be very clear, but this is like the cat that model object. This is like the bottle that it object. This is like the person, and I can just iterate over like different picture to see like what type of object was detected, and also I can see like the frame for each of these objects. So basically, there is no limit on the type of like model or code that you can bring to Tableau by using table extension. And the ultimate goal is just enabling like the end user who are not familiar with Python, who are not familiar with like machine learning, to just have access to this sophisticated model and combine them with the visual analytic. So that was like the end of the session. Thank you very much for joining this session. If you have like any question about Tableau, about like table extension, please feel free to reach out to me. My email address is amaimand@salesforce.com. You can find me on LinkedIn, my first name, my last name, Amir Meimand. And I will put all of this workbook along with like the Python code in my GitHub account. So please feel free to check it out, and you can download this workbook and Python code and just replicate this example for yourself. Again, thank you very much for joining this session, and have a great day. Thank you very much.